Hey y'all, this is a lesson on simplifying algebraic expressions and also applications of evaluating expressions. So they kind of go together, so I just put them in one lesson. Before we can get into simplifying expressions, we need to talk about like terms. So a like term has the same base and the same exponent. So I've talked about bases and exponents in my exponents video if you need to go back and watch that, but here's just a couple examples to show you what I mean when I say that. So some examples of like terms are, for example, 3x and 5x, because they both have an x to the first power. Another example would be negative 2x squared and 10x squared. They have the same base and the same exponents. So those are like terms. We could even do 3xy and 4xy. They both have this xy. So that makes them like terms. Some examples of things that are not like terms would be 3x and 5y. While they do both have the same exponent, the variables are not the same. So those are not like terms. Or negative 2x squared and 3x. They do both have x, but their exponents are different, so they are not like terms. And then 3xy squared and 4x squared y, they both have x and y, but the exponents don't match. They have to be exactly the same. So there's just a couple examples to help guide you. Like terms can be simplified by adding their coefficients. And then you leave the variable component the same. So for example, 3x plus 2x is kind of like saying 3 M&Ms plus 2 M&Ms makes 5 M&Ms. And then 3 Skittles plus 14 Skittles makes 17 Skittles. So what's happening here, just to kind of show you the mathematics behind it, is we're taking their coefficients and adding them together. So you're just adding those. And then this third example, we can't actually add them together because they're not even like terms. So we just leave it as is. It's done. And then a couple properties that are going to help us. These are common properties you'll use throughout mathematics. The commutative property basically means you reorder terms. So for example, 2 plus 3 is the same as 3 plus 2. Or 2 times 3 is the same as 3 times 2. You can change that order around and it doesn't affect the outcome. The associative property means that you regroup terms. So it's focusing on parentheses here. Associate is like groups, so we're talking about groups. If we have 2 plus 3 plus 4, I can regroup that to 2 plus 3 plus 4. And my result won't change. Same with multiplication. 2 times 3 times 4 is the same as 2 times 3 times 4. I'll show you in a second where this really comes in handy. Right now you might be wondering, why is she going over this? But this really does help. So, and then the last one is distributive. This one's probably the easiest to remember. if I have a number outside of a parentheses, I can distribute like that. Multiply outside by everything inside. So I mentioned I would tell you the point of the commutative and associative property. I want to show you just a quick example. Let's say I have, I don't know, something simple. If I have 50 plus 70 plus 50 plus 30, and I'm wanting to add those numbers together. In your mind, you might see automatically that I have 50s here, and I have the 70 and 30 here. You might see that. So you're actually using the commutative property when you reorder your numbers. And then we can kind of group those numbers. Let's see, so I can throw in the associative. And we're grouping them in hundreds. And we've used our properties, two of our properties. There's more properties, identity, inverse, reflexive, symmetric. There's more properties, but I just wanted to cover these properties for this lesson. Let's look at a couple examples here. These are really simple, very easy to do. We have 3 times x plus 5. When the 3 is directly outside the parentheses, that means times, which indicates that we need to distribute. So that looks like 3 times x and 3 times 5. And that's done. Number 2, we have this 2 here, so we're going to distribute 2 times 5x, 2 times 4. And then I need to bring down this negative 3. And these are like terms. So I can add them together. And that's done. That's an x. There we go. Ooh, this looks like fun. Going to distribute this 5. This is a negative 1. They won't write a 1. You can if you want to, but you will distribute that. And now we have some like terms. Yay! And we can join them together. So 15y minus 7y and negative 10 minus 2 is what we're dealing with. We get 8y minus 12. Dun, dun, dun. And I'm done there because this has a y and this does not. Last one up here. Ooh, this is fun. We have a parentheses inside of a parentheses. So I'm going to start here, see if I can simplify anything. I cannot. Outside there's a negative, so I am going to distribute first. Negative times negative is a positive. And then I'm going to write the stuff that I have not changed. Okay, be very careful here. You might be tempted to do 7 minus 4. Why can you not do that first? What do you notice about this 4? This 4 is attached to this group by multiplication. So this is a group, and we learned in our order of operations video that you have to simplify your group before you can deal with subtraction. So let's deal with this group first. Inside my parentheses, I do have like terms. So I am going to join those. I should make it green to keep with the color. And then now I'm done inside the parentheses, but I have this -4 outside that I will distribute. Seven minus 4 times 8 is 32. -4 times -4 is +16. So that's why we could not do 7 minus 4. It was actually 7 minus 4 times this stuff. And so it's hidden, but it looks like this instead. And now I have like terms again. It is -25 plus 16y. Done. And then this kind of plays into the order of operations lesson that I did in my last video. And then this lesson kind of plays into these problems here. These are kind of where you can see the real world application of these things. This is all very abstract, but this can help later in like formulas. These are formulas, algebraic expressions, that is showing the relevancy of these topics in real life. This formula expresses the relationship between Fahrenheit and Celsius, and this is the actual formula. We'll use this formula to convert a given Fahrenheit to its equivalent temperature on the Celsius scale. So we're wanting to convert 50 degrees Fahrenheit to Celsius. Let's look at this formula they gave us. If 50 represents Fahrenheit, where do you think you would plug that in? It might make sense to plug it in for F, since it's Fahrenheit. So let's try. 5/9, Fahrenheit is 50. Now I'm going to simplify, multiply. That would be 2. 5 times 2 is 10 degrees Celsius. Same thing with part B. I'm going to run out of room here. 5/9, Fahrenheit is 86. 5/9 times 54. That reduces, and we end up with 30 degrees Celsius. So if you're in a place where you use Celsius and you're used to Fahrenheit, then you know how to convert it. You could probably also use Google. But let's pretend like you don't have Google. Okay, another one. A football was kicked vertically upward from a height of 4 feet with an initial speed of 60 feet per second. This formula is what we need to focus on. Lots of words, but this is what we're focusing on. Describes the ball's height above the ground, h, in feet, t seconds after it was kicked. What was the ball's height 2 seconds after it was kicked? Okay, so they're telling us very important information. We have this formula that we will need. And it says h represents height and t represents seconds. It wants to know the height 2 seconds after it was kicked. So where do you think 2 seconds would go? H for height, T for seconds. It's going to go in for T. So let's plug that in. I'm going to do it in a different color so you can see. And then we have to know our order of operations to simplify. Here are my groups. So I'm going to simplify my groups. I got to keep simplifying. And then now I can subtract, add and subtract. And that is 60 feet. That is all for this lesson. I hope you enjoyed it. If you have any questions, please let me know, and I would be more than happy